This next problem expresses the number 5,197 in base 5. To do this, we will use basically a form of division algorithm, 5,197, and we'll just divide by 5 repeatedly. So 5,197 divided by 5 is 1,039.4, so I can write that as 5 times 1,039 plus a remainder. Now, we know what the remainder is by looking at the decimal, but we can do it the long way. 5,197 minus 5 times 1,039 gives me a remainder of 2. Not surprisingly, because 0.4 is 2/5. Now we continue again with 1,039. 1,039 is equal to 5 times 1,039 divided by 5 is 207, and 1,039 minus 5 times 207 is 4. Continuing, we have 207 is equal to 5 times something. 207 divided by 5 is 41.4. So 207 minus 5 times 41 is equal to 2. 41 is equal to 5 times 8 plus 1. We can do that in our heads. Then 8 is equal to 5 times 1 plus 3. And finally, 1 is equal to 5 times 0 plus 1. And so we're looking at the remainders going backwards. We have 131242. 131242 would be the way that this number is written in base 5. Okay, now let's double check that this actually works. Remember that this is 5 to the 0, 5 to the first, 5 to the second, 5 to the third, 5 to the fourth, 5 to the fifth. So if I take 5 to the fifth plus 3 times 5 to the fourth plus 1 times 5 to the third plus 2 times 5 to the second plus 4 times 5 to the first plus 2 times 5 to the 0. If all works out, this should be 5,197, and indeed it is. So that is using the division algorithm to get the answer. Another way of getting the answer would be to work simply more directly. So let me do this alternate route. So 5,197 okay, so I go 5 times 5 is 25. Third power is 125. Fourth power is 625. Fifth power is 3,125. I'm still not bigger than this. But if I go one more, then that would clearly be too much. So I can write 5,197 as 3,125, 5 to the fifth, plus something that's left, 5,197 minus 3,125 is 212072. Then we continue, 2,072. And this time I divide by 625. So 2,072 divided by 625 is 3, with the remainder of 625 times 3 is 197. 197, and this time I divide in 125, 5 to the third power. If I divide 197 divided by 125, clearly the quotient will be 1, 1.576, and the remainder is 72. Next, I'll divide in 72 and divide in 25. Clearly, that's going to be 5 times 2, 50 plus 72 with the quotient with the remainder of 22. 22 is equal to 5 times 4 plus 2. And then 2 is equal to 5 times, is equal to 1, 5 to the 0 power times 2, and there's no remainder necessary. So looking down, 1, 3, 1, 2, 4, 2, that's the same numbers that we see here. You should be able to convince yourself that these logically mean the exact same thing. Okay, let's now take a look at the same problem, but base 16. And before I get started, you should probably convince yourself that there will be less digits required because I have a bigger base of 16. Okay, now let me do this the second way first. 16 times 16 is 256. If I multiply it by another 16, 4096. If I multiplied it by another 16 after that, it'd be too big. So 4096 clearly times 1 plus a remainder, 5197 minus 4096 is 1111, or is it 1101? 1101 equals, okay, the next digit is 256, or the next power of 16 is 256. So divided by 256 is 4 something. So quotient of 4, and the remainder will be 77. 77. The next power is 16 to the first power. So 77 divided by 16 is 4. And then 77 minus 16 times 4 gives a remainder of 13. And finally, 13 is equal to 1 times 13 plus 0. And so reading the digits down, we have 1, 4, 4. Now 13 we don't write as 1, 3 in base 16 because we have to write this as a single digit. So remember that A is 10, B is 11, C is 12, and D is 13. So it would be written as 144D in base 16 in hexadecimal. So 1 times, I'm going to let you confirm this. We have 1 times 16 to the third plus 4 times 16 squared plus 4 times 16 plus D, which is 13. This undoes all the work that we did here, and we should end up with 5,197 again. And I'll let you double check. Also, the other way of using the division algorithm gives the same answer as well.